I actually started with personal computers back when I was in high school, and this was the 1980s when personal computers first started hitting the market. And even though I enjoyed them very much, it was sort of a mystery about what went on inside of them with the circuits and transistors and things like that. I did, however, realize that it all took place on a printed circuit board called the motherboard. It was called the motherboard because a number of different components plugged into it. Motherboards have evolved substantially over the years. Expansion card bus, memory types, processors have all moved forward with new technologies. And because of that, you need to be aware as a computing professional what motherboards offer, the technologies that they use, and the way that you can select the best type of product for whatever customers you may support.
One of the first steps we want to do is just sort of look at the common components that are pretty much a part of every motherboard type of construction. And to some degree, this has been the same since the dawn of time as far as computing is concerned to many things that are going on today. So let's look at these now. Now again, in terms of computing, the motherboard is at the center of the world of internal operations. Now really in the simplest of terms, if you want to boil it down, a motherboard is basically a large circuit board, we'll talk about form factors in a minute, with electrical pathways printed on its surface and the various parts soldered or somehow affixed at various points. Now during this particular lesson we're going to consider the various aspects of this very important component, but for now let's just look at some of the major features. The first is the central processing unit, or CPU. It's essentially the brain of the computer, and this chip executes instructions and pretty much drives everything else inside of the device. Now I do want to point out that the arrow in this particular diagram is pointing directly at both the heatsink and the fan as well as the CPU. The CPU actually sits underneath all of that. The fan first, the heatsink second. We're going to talk about more of those in the lesson on cooling. And then of course the CPU itself, which is actually plugged into the socket on the motherboard. We're actually going to get much deeper into processors, so that's all we're going to say at the moment. Next, you have a power connector. One of the things that you need to understand is at its very essence, a computer is an electronic or electrical identity, and it requires electrical input from a power supply that provides reliable power at the right voltage and at the right current settings. We'll also deal with power supplies in a separate lesson. If the CPU is the brain, then the power supply would essentially be the heart. That's all we'll say for now. Next, you have disk interfaces. Various different types of drive exist for computer systems for long-term storage, including hard disk drives, CD and DVD drives, and so forth. Next, you have a series of external ports, which actually connect the motherboard to the outside world. And this also empowers the use of an entire host of devices, such as printers, keyboards, monitors, networks, and so forth. And you have memory slots. The number of slots and the type of memory that takes will be a topic of another discussion, but there's quite a bit of variation over the years. But as we talked about earlier, computers require short-term storage for various purposes, and this takes the form of smaller circuit boards with specialized chips called RAM, which stands for Random Access Memory. There's a lot of different capacity chips available for installation depending on the requirements of an operating system or some other thing you may be using that system for. Then you have expansion slots, and this is a feature that dates back to the very first personal computer that IBM introduced. And these accommodate other circuit boards called expansion cards, which actually provide a number of additional features and capabilities to the device. As with these other components, we'll have more to say about that later. And there's a lot of other aspects of the motherboard that certainly deserve discussion, but this first initial discussion is just an overview. Now that we've walked through all the major parts, let's drill down into deeper detail on the architecture of this particular component. Motherboards have come out with a number of different dimensions over the years, and it's important even in the modern context of computing to understand what these dimensions are. The term for this is form factors. We actually want to look at the ones that are out and even some into the past now. Now for computers of fairly recent vintage, the typical form factor is called ATX, and this is the basic ATX layout right here. It stands for Advanced Technology Extended. Now the layout and the number of some elements are going to vary, but the basic componentry is laid out here. Standard specifications are 12 inches by 9.6 inches, but there's smaller versions of this size as well. Now, the specifications originally called for 7 expansion slots. We only pictured 4 here. And a slightly smaller version called Mini ATX has dimensions of 11.2 by 8.2 inches. So standard ATX and Mini ATX. See the dimensions as we discussed. There's also a Micro ATX form factor. And the Micro ATX form factor shrinks the dimensions from 12 by 9.6 to 9.6 and 9.6, forming basically a smaller square, and calls for 4 expansion cards. We have 3 pictured here. The Flex ATX form changes the layout and the size a little bit with a 9.0 and a 7.5 set of dimensions with 4 expansion slots. And again, we just have 2 depicted here. Then you have the Mini ITX. Now, the Mini ITX was actually preceded by the standard ITX motherboard form factor, but it wasn't really out very long, and Mini ATX basically took over the same place. It seems like very, very small specifications because you have 6.7 inches by 6.7 inches. Expansion cards are pretty limited, usually calling for the use of what are called riser cards. So typically you see the expansion cards that are depicted here. You actually would have one on the motherboard, and then there'd be an adapter that would plug in perpendicular that would actually allow for additional expansion cards. And there's several types of riser cards, as they're called. Another essential area with regard to personal computing motherboards is understanding how they are built. We call this motherboard architecture. This kind of gives you an idea of how the motherboard does what it does and what it adds to the personal computing environment. Now, one important concept to understand, and this is true with computers in general as well as motherboards, is the concept of a bus. Now, honestly, when you hear the word bus in common everyday language, you think of an actual bus that on wheels that goes through the city, public transportation, that sort of thing. But the bus is actually a connection pathway for electrical circuits where wires interconnect. So it's less like this picture and more like this. This is actually an electrical closet where wires interconnect. This is the concept of a bus. It's an interconnection point for electrical circuits. Now, specifically relating this to the computer motherboard, a bus is a series of electrical pathways or circuits used for carrying information. Specifically, electrical impulses, using a series of pulses to generate either a 0 or a 1 binary to convey information. And this is simply because circuits can only have 2 states, on or off. Rather than the system being composed of just one bus, however, there are typically several inside the computer. Now, to get an idea of how different electrical buses come together, let's start with the heart of the system, the CPU or processor. Now, the second and third elements are specialized control chipsets designed to work with specific processors, and they are as follows. First, you have what is sometimes called the North Bridge. This is actually a memory processor chipset, and again, it's sometimes just referred to as North Bridge or the memory hub. It's basically graphics and memory. Next, you have the South Bridge. This is the input-output controller or I/O controller chipset, and it deals with drive interfaces, external ports, and expansion slots. Now, understand that buses come in widths, just as you have highways that have certain widths. It may be a 2-lane highway or a 4-lane highway or an 8-lane highway. You could think of the width of the bus being the capabilities and speeds that are allowed. In this case, it's in megahertz or gigahertz, and basically just indicates the speed by which the bus can transmit traffic. Ultimately, the bus width is the number of bits that the bus can carry at one time, whether it's 8-bit, 16-bit, 32-bit, and so forth. And the bus speed is how fast that data can be moved across the bus. And again, this is usually measured in megahertz, more popularly now in gigahertz, which is millions of times per second. So let's just talk about the various bus types. We already have one introduced here, and this is what's called the front side bus. This is a high-speed bus, remember circuit pathways, that carries data between the CPU and the North Bridge. It's sometimes called the CPU or processor bus, and usually it's the fastest one within the system. Next, you have the graphics bus, and you see here we have a video card slot depicted. It connects the CPU to the graphics processor or the embedded graphics port if there is one. Various different types of adapters have existed over the years, and we'll talk about this a little bit later with expansion bus capabilities. But you had ISA, PCI, AGP, and PCI Express, and actually we'll touch a little bit on this later. Next, you have the expansion bus. Remember those expansion slots we were looking at on the motherboard at the very beginning of the lesson? This is where the expansion bus comes in, connecting through the South Bridge and adding functionality to the system. This began what was called the ISA, or Industry Standard Architecture bus, but later it was replaced by PCI, Peripheral Component Interconnect, offering even greater speed and flexibility. Now you have PCI Express, which is the standard on pretty much all systems. And additional connections are made possible by the connection of the system BIOS, audio, USB ports, and disk drives. Now the very first type of expansion bus was called ISA, or Industry Standard Architecture, and you see an example of it here. And it was very slow and limited by today's standards. It's entirely obsolete and no longer used, and you're very, very, very unlikely to encounter it in the field. It was replaced by the PCI bus, which is what you actually see circled here now. And for a time it coexisted with it a lot, like it is on this particular motherboard. But it multiplied the bus width and the speed several times over. The original PCI standard, whether it's 1 or 2.0, supported cards running at 3.3 or 5 volts, depending on the keying of the slot, and the keying is that little white connector piece that you see coming across. It's supposed to prevent you from putting a card that's not compatible. And it would be either 64 or 32-bit. And eventually, there were ways that were sought out to actually separate the graphics feature, which actually gave way to what's called AGP, or the Accelerated Graphics Port. Now, the AGP approach to video allowed for faster processing, 3D rendering, which was very popular for gaming support. And it made a really big splash in 1996 when it was introduced, but it has been replaced, as this is one thing you're going to see consistently in computing, it was replaced by something much faster and more efficient. In this case, it's PCI Express, or PCIe, which is actually the expansion bus used most popularly today. And here you see an example of the PCI Express bus. It's not backward compatible with the PCI standard we showed a little bit earlier. It uses a serial bus to send data, and each PCI slot connects directly to the south bridge. You have a number of different sizes that are available. You have X16, this is standard PCI. You have an X1 that you actually see there. You have X16, and so forth. Now, among the other connectors on the motherboard, a specialized connection mechanism exists for the processor. And in most computers, this is always a socket, as you see illustrated here, just about in the center of this particular image. Now, while we consider processors in a separate lesson, it's important to understand the socket types, because the socket types drive the processors that are allowed to be used with that particular system. The first type is the pin grid array, which you actually see depicted here. Now notice here the pins are aligned in rows. Two different installations exist for pin-based sockets. The first is called low insertion force, which means you line up the processor pins with the socket and gently push it in. And the idea is if you have too much force, you'll break the chip. So low insertion force allowed it to be easily put in. Then you have ZIF, or zero insertion force. In this case, you lift a lever, as you actually see here, which loosens up the contact springs in the socket. Then when you're putting it in, you line up the pins, you let the processor drop into the socket without any force, and it'll slide into the socket. And then you lower the installation lever, and it actually locks it in place. So that's a pin grid array, or PGA type socket. Next, you have the staggered pin grid array. You notice here that one row is perfectly aligned and the other is offset from it a little bit, and the other one aligns offset as well. And this is just another type. Pins are staggered, and the idea here was to be able to fit more pins or more connections into the socket mechanism. In theory and in practice, actually making it quite faster. Next, you have what's called the land grid array. If you actually look at the processor here, it does not have pins. It actually has metallic surfaces that then align to the socket underneath. So there are no pins, so the pins can't get bent. It's less susceptible to damage. And in fact, the computer that we'll be building throughout this particular course actually uses a land grid array processor socket. So you still have your socket lifting lever and the socket lands, as they're called, to actually interconnect to what's on the socket. And there's the contacts. Pretty much you can see how it lines up by the little picture off to the right-hand corner.
In just a moment, we're going to proceed with the installation of the motherboard, but it's very important that we take note of electrical safety first. One of the things that can happen in touching computer components is what's called electrostatic discharge, or ESD. The way to prevent that and damage to the components is to use a device like this called an electrostatic wrist guard. You can see it just very simply slips on like this. There's a little alligator clip at the end, and it's important to be able to place this on some metal portion of the chassis. And now we're grounded and ready to proceed. So now that we're properly grounded, we're ready to proceed with the installation of the motherboard. You can see it's actually inside an electrostatic bag. This, again, offers additional protection against potential static discharge. We remove it from the bag, and then we're ready to proceed. It's important to align the holes at the rear of the case where the ports are. And next we will secure it so that it doesn't move. Sometimes the screws like to be a little cantankerous. It's important to be able to have this properly affixed before proceeding. Now we won't take the time to put the rest of the screws in right now, but you can see now that the motherboard is installed, secure, and ready for the installation of additional components. Thanks for listening.
Let's just go over a couple key terms. Form factor, design parameters of a motherboard that define the size and shape, ultimately the dimensions of that particular device. A bus is an electrical pathway on the computer motherboard used for transmitting data between components. We talked about front side bus, graphics bus, expansion bus, and so forth. An interface is the connectors that allow a device to connect to a motherboard, for instance, hard disk drives, floppy disk drives, CD and DVD drives, and so forth. And then you have the CPU. This is the main computer processor that is responsible for managing and performing all the work that a computer produces.
So as we looked at, there's a lot that goes on in the circuit pathways of a motherboard. And even though it's a critical component, like a lot of things in life, it cannot do it alone. It requires other components to accomplish a number of the different tasks that go on inside the computer. These other components, as we'll explore later, is what you could call the rest of the story, the additional functionality, expansion, and so forth that comes along with the whole world of computing. We'll take a look at that shortly. Thanks for listening.